if your bank or creditor, or for that matter you, want to make more money on an investment or a loan.
Show me the money! That's it, brother, but you got to yell that shit! Show me the money! I need to feel you, Gary! Show me the money! Gary, you better yell! Show me the money!
Instead of just talking about simple interest, you can also talk about what is called compound interest, where compound interest looks at a case in which the interest rate is both going to talk in terms of the principal as well as the value accrued over time in interest. So thinking back to that original case we were talking about the simple interest of that nice, let's say unrealistic promotion by the credit union. In the second year, you'd not only be talking about the interest accrued from the original $500, you'd also get an amount of interest from the $10 included as well from the first year. That's what's called compounding interest, where the factors come into play from both. And the idea here of compounding interest dates back to the Romans and even earlier, where, according to some texts, this was in particular considered the worst form of usury because of how quickly these things could grow, and the ideas for understanding them would continue to develop in Italy through the 14th and 15th century in terms of tables of values for approximations and the rule of 72 for similar purposes, where talking about these things more exactingly would really get a big development from Jacob Bernoulli in 1783 with the value E, but we're going to talk more about that in a couple minutes here, so I'm going to save that for later. The main thing we need to understand here is that if we want to talk about the value A, the future value, that's going to be in terms of, well, for one, there's something in here that I'm missing that's very important. The principal investment P times the value 1 plus R, but instead of multiplying R times T, we raise this whole thing to the power T. We're basically going to think of this as saying that every time we talk about the interest rate accruing, instead of having a factor of T on top of R, we get a factor of an entire 1 plus R, because that gets accumulated along with the interest on principal. But, again, I've said the words interest and principal and accumulated a few times. It's really a lot easier to understand how this works with a basic example. So suppose the student loan debt from the previous section example had compounding interest that compounded yearly. What would the value of the debt be after 4 years, assuming that none of it was paid off? So it is an important detail. We're talking about it compounding yearly. That means that at the end of every year, at the end of every value T, the value in there will recompile in terms of the interest rate. So assuming that nothing changes, just for context, if we had simple interest, like we saw last time, we would have A is equal to 35,500 plus the value after 4 years that we got, which was 4970, for a total of 40,470. Meanwhile, if we take compound interest, we're going to find that this is a little bit different, because there we have A is equal to P, still 35.5, but instead of being multiplied by 1 plus RT, now we're going to have 1 plus our value R, which remember was that unfortunately reasonable value of 7%, raised to the 4th power. And what we're going to see here is something that you guys probably don't have a lot of context for, but the the significant difference in the rate at which things in exponential forms grow as compared to things that are just like nice polynomials, addition, subtraction, maybe multiplication. This is a much faster description of value, and as a result, our value after 4 years that you will be owing ends up being $46,533 and about 26 cents. So over the same period of time, over $6,000 more, which again shows how much faster this type of thing grows, and also might give a bit of an argument for why the Romans didn't want people using loans with this type of interest rate. But we can make this actually even more of a fast-growing value by talking about the amount of times that this interest compounds. Because we look here at interest compounding once per period t, as it were, but there's no reason for it to just happen the one time. And that's where we talk about the general formula for compounding interest.